Hey guys, I just wanted to make a quick video about how to read pressure maps or Isobar weather maps. So these maps are really good for just a quick and dirty sort of overview of what the wind is going to do on a given day um, over a really large area. So yeah, these maps are really useful for surfing, in particularly, and boating um, or just like it'll give you an idea of what the weather is likely to do throughout the week as well. So basically, the main components of these weather maps are obviously the high pressure and the low pressure. So this just represents air pressure at surface or at sea level. So here we have a high pressure, here we have a low pressure. So you can imagine the low pressure being like a vacuum. So this represents air that's rising or being sucked to the upper atmosphere, whereas the high pressure represents air that's being forced downward and outward from the upper atmosphere. So this is pretty much like an air gun being shot to the surface. This is like a vacuum cleaner being having air sucked away from the surface. So basically, the anticyclone here. Okay, this video might need some editing. So basically, we have we have air moves from high pressure to low pressure. It's going to go from where it's being pushed downward to where it's being sucked upward. So air is going to flow straight from high to low, but there is a catch. Basically, because the Earth is spinning, air movement from the high pressure to the low pressure is going to be deflected to the left in the southern hemisphere. So this is just an effect because of the motion of the Earth. So this is called the Coriolis effect. So in the southern hemisphere, airflow gets directed to the left. So this starts flowing. So the air around a anticyclone, if air moves from high to low, then air is going to go like this, and then gets deflected to the left, and then it forms this anticyclonic circulation pattern around that. So the motion or the wind is driven by the gradient or the need for air to get from high pressure to low pressure. And the higher the difference between the high pressure and the low pressure, then the greater the air flow. So the same is true for the low pressure. So any air flowing into the low is going to also be deflected to the left. So around a low pressure, when you've got air coming here this way and being deflected to the left, it forms a clockwise motion, or what we call a cyclone. So because air's being deflected to the left around an anticyclone, there's anti-clockwise motion. So that's called an anticyclone. So anticyclone, cyclonic, or cyclone. So this is really good because so these maps are really good because at a glance we know that air is going to flow in this clockwise motion around a low pressure system and anti-clockwise motion around a anticyclone. So now we know roughly which direction the wind is going to blow. Now the next thing to note would be how close these lines are together. So the closer the lines are, and the lines just represent equal lines of pressure. So if you've got closer lines, that means that the pressure gradient or the steepness of the pressure difference, so the pressure difference will be greatest where the lines are smallest or closest together. So that means that the wind in this particular location, it's going to be stronger. So just looking at this map, we can see that there's this big anticyclonic weather system. This wind is going to be flowing right across the southern part of Australia, and it's going to be going all the way up in this sort of motion. And here we have a deep low pressure, and the direction of the lines gives you a rough understanding of which direction the air is coming from. So we know that basically there's going to be a lot of air blown up from Antarctica that's going to be funneled right up and into New Zealand. And so this weather system, this pattern will generate a lot of cold weather. So one important aspect to note about the properties of the high pressure and the low pressure systems. So the high pressure has cool, dry air because the air being forced down comes from the upper atmosphere. That air has lost a lot of moisture. There's not much moisture in the upper atmosphere. Whereas the low pressure, all the air is being channeled in to the low from the surface, and the surface has moisture-rich air because all the evaporation from the ocean, water sources, all that evaporation contributes to the moisture in the air. And then when that air flowing along the surface encounters the low pressure, because it gets sucked to the upper atmosphere or it rises, then as that air mass rises, the air cools, the water condenses, and clouds and rain begin to form. So this is why cyclones are typically associated with wet weather, whereas the high pressures are usually associated with a large, calm area of nice weather, no rain, light winds. Whereas, yeah, the low pressure, they have very stormy, cold kind of conditions. So here we have a high pressure. So because the pressure gradient is so high, that means that the winds are going to be really light and we're going to have nice weather. So yeah, I hope this tutorial has kind of shed some light on what makes pressure maps useful, and hopefully has given you a rough idea of how to read them. So thank you, and if you have any comments or questions, let me know, and I'll try to get back to you.